right, welcome to this explainer. Today, we're diving into something that frankly feels like it's straight out of a sci-fi novel, except it's actually happening right now in labs and hangars all over the world. We're going to explore how we are literally unlocking the universe's ultimate energy source and how it's gearing up to completely revolutionize the way we travel across the planet.
So here's a crazy question for you. How exactly do you fly a plane at Mach 5? We're talking 5 times the speed of sound, while leaving absolutely zero harmful emissions behind. You know, traditional aerospace engineering tells us that the sheer amount of thrust and fuel you need for hypersonic speed makes a massive carbon footprint pretty much inevitable. But what if the answer to this whole futuristic paradox was actually the very first element ever created in our universe? Today, we're revealing the exact technology making the seemingly impossible feat a reality.
Okay, let's dive into this roadmap. 1. Meet the water producer. 2. The aerospace revolution. 3. Inside the fuel cell. 4. Types of fuel cells. And finally, 5. Powering tomorrow's propellers.
Section 1. Meet the water producer, the most abundant element in the universe. To really wrap our heads around the sheer scale of the resource we're dealing with, we actually have to rewind the clock all the way back to the Big Bang. Hydrogen is totally, unequivocally dominant. If you look at the mass composition of the visible universe, hydrogen makes up about 74%. It was produced right out of the gate after the Big Bang. Helium takes up 24%, oxygen 1%, and literally every other element you can think of shares that final tiny 1% sliver. So we're talking about the most plentiful chemical element in existence. The scale of this resource is practically limitless. Even the name itself tells a story. Etymologically, the word hydrogen is a mashup of 2 Greek words, hydor and genen, which translates directly to water producer. Sitting right up there in the top left corner as number 1 on Mendeleev's periodic table, it's the lightest chemical element we have. It's a colorless, tasteless, and odorless gas, and it's highly reactive with oxygen. But here is exactly why aerospace engineers are so obsessed with it. When you look at its energy density, hydrogen packs 143 megajoules per kilogram. That is 3.33 times more calorific value than the everyday kerosene or diesel fuels we use to run the world today. It packs a serious punch. But historically, extracting it has been a really dirty process, and that is where a vital distinction comes into play. Enter green hydrogen. It's so crucial to understand what makes this specific type of hydrogen a total game changer. Green hydrogen is made by splitting water into hydrogen and oxygen, a process called electrolysis, but the catch is it uses electricity derived exclusively from renewable sources. Think solar, wind, or tidal power. Because of that, when you use it as a power source, it releases 0 harmful gases, completely erasing the environmental footprint we usually associate with extracting energy. Section 2. The aerospace revolution. Mach 5 jets to commercial airliners.
And this brilliantly illustrates what happens when you take this immense, clean power source straight to the sky. Meet the Destinus. This is a prototype from a European startup aiming to build a hydrogen-powered hypersonic plane. Designed to hit Mach 5, this team hopes to be flying passengers after 2030, cutting travel times by a staggering 2/3. Just imagine boarding a flight in Germany and touching down in the US in only 2.5 hours. All of it powered by hydrogen engines. Absolutely wild. Now, this ambition scales perfectly into commercial flights too, with Airbus's Zero-E concepts. You've got your familiar turbofan models powered by hybrid hydrogen engines, sure, but then there's the radical blended wing body design, which allows massive hydrogen storage tanks to be integrated directly right under the wings. It's a perfect example of how this new fuel source isn't just swapping out gas, it's dictating entirely new, highly efficient architectures for the aircraft itself. And hey, this isn't just some distant whiteboard theory. Rolls-Royce and EasyJet have already crossed a massive aviation milestone. They successfully ran a modified commercial gas turbine engine purely on green hydrogen. This landmark test is absolute proof that green hydrogen is already viable in modern, modified engines. It's paving the immediate way for a net zero future in aviation. Section 3. Inside the fuel cell. The magic trick of electrochemistry. Okay, so now that we've seen these massive aircraft on a macro scale, let's pop the hood and uncover the microscopic magic happening inside. Think of a fuel cell as performing this incredible magic trick using electrochemistry. See, traditional engines burn fuel, but a fuel cell produces electricity cleanly and efficiently without burning a single thing. It acts a lot like a battery, but as long as you keep feeding it green hydrogen and oxygen, it literally never needs recharging.
And the only byproducts? Electricity, heat, and pure drinking water. Actually, fun fact, in space missions, this exact process is used to generate the crew's potable drinking water. So the crucial point is how this step-by-step process actually works. First step, hydrogen gas is introduced, and it hits an electrode called the anode. Right there, a catalyst splits the hydrogen molecules. Second, the released electrons are routed through an external circuit, and boom, that creates the direct electric current used for power. Third, the remaining hydrogen protons move straight through a special electrolyte membrane. And finally, on the other side, at the cathode, those protons and electrons reunite. They meet up with oxygen, and they form hot water. That's the whole shebang.
When you compare this to an old-school internal combustion engine, the leap in efficiency is staggering. An internal combustion engine is this clunky, multi-step, loss-heavy process, right? It burns fuel to create heat, uses that heat to create mechanical energy, and then turns a generator for electricity. A fuel cell skips all of that nonsense. It directly converts hydrogen and oxygen into electricity and water with zero emissions. It's just a vastly more productive, streamlined system.
Section 4, types of fuel cells. Different tools for different jobs.
Now, it's kind of like a toolbox, right? You wouldn't use a hammer to turn a screw. Engineers have developed different cells for entirely different environments. There are three main categories we care about. First, the alkaline fuel cell, or AFC. It works at lower temps and has historically been the workhorse for space travel and submarines, though its lifetime is a bit short. Then you have the phosphoric acid fuel cell, operating at high temperatures. It's super tolerant to impurities, which makes it awesome for static power in commercial buildings, but it's way too heavy and stationary for aerospace. But then, there is the proton exchange membrane, or PMFC. This is the star of our show. It operates at low temperatures, has incredible power output dynamics, and critically, it minimizes size and weight, which makes it the absolutely perfect tool for aviation, space travel, and modern transport. Section 5, powering tomorrow's propellers, building the zero-emission future. So research institutes are grabbing this PEM fuel cell and literally building our zero-emission future as we speak. For instance, take a look at this hybrid scheme from a real-world project by INCS, the National Institute for Aerospace Research. They are right now building an experimental stand to power an aircraft with a maximum takeoff weight of about 1,200 kilograms. The whole system runs on this beautiful continuous flow. Hydrogen and air feed into the proton exchange membrane fuel cell. That generates electricity, which zips through a power management system, getting a little boost from batteries during peak loads, and flows straight into an electrical motor that spins the mechanical propeller. Any heat and vapor are just cleanly vented away. It is an incredibly elegant and mission-free propulsion system, coming to life right before our eyes. And that brings us right back to the core thesis of this explainer, which was perfectly summed up by the researchers themselves. Green hydrogen is an environmentally friendly power source that reduces or eliminates the environmental footprint. You know, we aren't just talking about swapping out one liquid for another at the fuel pump. We are talking about a fundamental structural revolution in aerospace. From the very shape of the planes flying overhead to the electrochemical reactions silently powering them from the inside. So I want to leave you with this thought. We are currently mastering the universe's most abundant element, the stuff that makes up 74% of everything we can see, to push commercial flight to Mach 5 without leaving a single trace of pollution. As this technology matures, what other seemingly impossible boundaries is green hydrogen going to allow us to cross next? Thank you so much for joining this explainer. Keep looking to the skies.